Hey everyone, this is day two of building my portfolio project, LakeMind. In day one, I introduced the high-level architecture, the business use case, and the tech stack I'm going to use as part of this project. Today, I'm going to focus on the data set and also the entity relationship diagram, along with the medallion architecture itself. Okay, it also says that a pipeline is only useful when the data model is clear, right? So for our LLM model to give right answers as per the data, we should have a solid ERD. So that's one of the main reasons why we are, even building it in the first place, to avoid wrong joins, to not report duplicate metrics like wrong, revenue or number of customers and so on, right? So that is the main purpose of we building ERD. Then it comes to in real life, right? For example, a real life data engineering project, we build ERD in three stages. One is the conceptual stage where we sit with the business users or the domain experts, try to gather the uh, key entities that are associated with the business. Then comes the logical, where we define the keys, table grain, and the relationship between them using analysts or data architects. Then it comes down to the final physical model where we decide the type of storage that we want to use, whether it be Parquet or ORC, and also the validations that we need to perform on the tables itself, like duplicate check, count check, null check, and so on. This is usually performed by data engineers or platform engineers. So, but in our case, uh, our data in data source already has these entities in terms of CSV files. So the in this project, we use this Brazilian Olist e-commerce dataset. It has 9 CSVs covering from customers, orders, payments, reviews, geolocations, and so on and so forth. So this is a realistic multi-entity e-commerce dataset, which is very useful for learning the data modeling and pipeline design. So, right. So talking about the important component of this dataset is the orders. The reason why is because it's the center point of the whole business. Uh, Customer places an order, orders are associated with the items, orders are associated with the payments, and orders are associated also with the reviews. So, orders are the main important table for us, and even this entity relationship diagram, if you see, uh, the orders is a central table. Let me zoom in a bit, and everything revolves around it, be it items, payments, reviews, sellers, geolocations, customers. So customer place orders. Orders are associated with multiple items. Each item has a product name, category, description, height, weight, width, and so on and so forth. There's also translation table where we translate the local language of Brazilian product category into the English name. Then we have the sellers details, who actually sell the products in the e-commerce website. Then we have the payments associated with the orders. Then we have reviews associated with the orders. One order can have multiple reviews. We will see the relationship in detail. Customer Customers are located in certain geolocation, and the same goes for sellers as well. So this is the overall ER diagram. Now let me go through the relationship itself for each entity. So customer entity and orders one to many. One customer can place many orders. One order can have multiple items. One order can also have multiple payment methods, be it debit or credit card, or so on. Orders definitely can have multiple order reviews. One order item will be associated with only one. Many order items can be associated with one product, right? So that is many to one. Order item sellers, basically one seller can have many order items that can be sold, right? So that's many to one. This is also fine. Customers and geolocation, one geolocation there can be multiple customers. Similarly, that goes for sellers as well. So this is the key relationship cardinality that we have for each entity that is defined here. Next up, we have the ERD medallion layers. This is where the bronze, silver, and gold layer comes into picture. In bronze layer, I'm going to preserve the raw source table as is. I'm just going to ingest the CSVs into the Parquet tables in my local file system, and it'll be the source of truth. Let's say in silver layer, I mess up some logic, and the data will be incorrect, right, in silver layer. So I always have a source of truth. I can go back and rebuild my silver layer using bronze layer. So that's the use of bronze layer. So silver layer, I'm going to clean up a few of the uh, columns. Like I'll correct the data type. I'll clean up some null values and so on and so forth. Gold layer is typically where you aggregate the data and bring in the KPI values. So the granularity might change between gold layer and silver layer. That is the main difference that we're going to discuss in detail in the future. Yeah, the next steps would be for us to build the actual ingestion layer itself for the bronze data. Then I'm going to build silver and gold layers once I have the ingestion data into my bronze DB. Then also we have an interesting part where I am going to build uh, query UI. Basically, all the data that we've dumped into bronze, silver, and gold, we want to query the data, right? So I'm going to build a simple Streamlit based application where I can try to query the tables that are associated in each of these folders called bronze, silver, and gold, and also analyze the data that way. So that's all for today. Uh, that was day two of LakeMind. So follow along if you are into data engineering or GenAI platforms. We will build this from scratch, step by step. Thank you.